All right, my friends, sorry that last video got cut off. I have some guesses as to why that happened, but I'm not completely sure. So let's look at a second example for Euler's method. So let's say you're given dy dx is equal to y minus x squared, and an initial condition that f of 0 equals 3. You're asked to use Euler's method with, I'm going to say 2 steps of equal size. To approximate f of 1. Okay, so I've used a little different wording here on this one. Instead of telling you the step size, sometimes they'll say how many steps they want you to take, and then they'll always have them be of equal size for Euler's method. So let's think about that. You need to get from an x value of 0 to an x value of 1, and you're supposed to use 2 steps. So you need to get from 0 to 1, so that's 1 unit, and you're supposed to do it in 2 steps. So that means that your step size, actually sometimes referred to as delta x, as in your change in your x value, is going to equal half a unit. Okay, so now let's go ahead and go through this problem like we did in the last problem. So round 1, remember, is to find the equation of the tangent line at your initial condition, which would be the point 0,3. And to do that, we'll figure out what dy dx is at that point. So with Euler's method, the one thing you can be sure of is your slope is always correct. It's always matching the curve of the graph. So at 0,3, let's say I'd put 3 in for y and 0 in for x, so I'd end up with 3. So then the equation of that tangent line would be y minus 3 equals the slope times x minus 0. Isolating y would give you basically y equals 3 plus 3x. Okay, now we said we're going to use a step size of 1/2, and we just found the equation of the tangent line at 0. So we're going to increase that x value by 1/2, and so now we're going to plug 1/2 into this tangent line. So y, when x is 1/2, would be 3 plus 3 times 1/2, which I believe would be 4.5. Like so, okay? So now for round 2. So find the equation of, and this time it's not really tangent because this point right here, 1/2, 4.5, is probably not exactly on the actual graph of f. It's probably pretty close though. There we go. So we're going to go back to the given differential equation here. And evaluate it at 1/2, 4.5. Okay, so we're going to put 4.5 in for y, which I think I'm going to put that in as 9/2, and we're going to put 1/2 in for x, so we'd have 1/2 squared. So you're going to end up with 1/4 here. 9/2 is equal to 18/4. So we'll have 17/4. Good times. Okay, so now let's get the equation of that tangent line. So we'd have y minus the 4.5, which I think I'll put 9/2 here for that, equals 17/4 times x minus 1/2. Okay, isolating y would give us 9/2 plus 17 over 4 times x minus 1/2, like so. So this is that second tangent line to the graph, not really tangent, but it's following the shape of the curve, but it's probably a little off. So, and this was at 1/2. So now we're going to increase 1/2 by our step size. So 1/2 plus 1/2 is 1. And so we'll evaluate on this line graph, what do you get when you plug 1 in? Like so. So we'd end up with 9/2 plus 17 over 4 times 1/2. Let's see, 17 over 4 times 1/2 is 17/8. So we need to multiply this by 4 over 4. So y, when x is 1, would be, what is that? 53 over 4? Or 53, yeah, 53 over 4, looks like. Okay, so final answer, this is on that kind of second line graph. So it's not f of 1, but it's probably pretty close to f of 1. So there we go. All right, my friends. And I don't know if I made this comment in an earlier video, but the smaller your step sizes, the more accurate Euler's method is. But on the AP exam, they've always just had you do a small number of iterations of the process, in which case this tangent line method works really well. If you were to take a differential equations course, well, maybe differential equations, they would do Euler's method, and then maybe like a numerical methods class where you do this with a lot of accuracy, you would probably switch to a tabular method, or even probably just programming, making a little program to do it for you, just based on the concepts though that we're doing here. So we're keeping Euler's method very simple at this time, okay? So the next problem we're going to do was a problem that we had originally skipped on the multiple choice section from the BC multiple choice. It was problem 3 on the multiple choice section. I'm just going to turn it into example 3 here. And this will be our last example. So it says the table gives, selected values for the derivative of a function g on the interval from 1 to 2. If g of -1 is equal to -2 and Euler's method with a step size of 1.5 is used to approximate g of 2. What is the resulting approximation? Gotta love the wording they use for some of these questions. And then here would be the given table. So one column says what x is, and the second column gives the resulting derivative of g at that x value. so. Okay, perfect time to pause the video and see if you can do this on your own. I'll just go ahead and go through it though. So round one would be to find the equation of the tangent line at the initial condition. So, so that would be, the initial condition is that the graph hits the point -1, -2. And then get the slope of the tangent line, which actually they're not using dy dx, they're using g prime. So g prime of, at this point, would be -1. So pick out the appropriate value on the table, which would be right here. So g prime of -1 is 2. Finding the equation of the tangent line to the graph of g at that point would be y plus 2 equals your slope times x plus 1. Isolating y. And then it said to use a step size of 1.5. So if you take this x value that we just used, -1, increase it by 1.5, you get 1/2. So plug in 1/2 into this line graph. Like so. Simplifying that, let's see, that's 3/2 times 2 is 3. Like so. Okay, so now we'll move on to round 2. So we're going to use the point 1/2, 1. And then we're going to figure out what's the slope of the tangent line to the graph of g at 1/2. So using the table, using the appropriate row for that, you'd end up with 1. So you'd have y minus 1 equals your slope times x minus 1/2. Isolating y. And then using your step size, they said step size of 1.5, you're going to go from 1/2, you're going to increase that by 1.5, and so you'll end up with 2. So y, when x is 2, two minus 1/2 is 1.5 times 1, and then plus 1, you get 2.5. And then that would be on that second line graph, and so this would be approximately what you'd get on the graph of g at 2. There you go, which turned out to be option D on a multiple choice question. All right, my friends, I hope this makes sense. If it's not, I hope that I'll hear from you about it, and I hope everybody's doing great. Talk to you soon, or talk at you.